Okay, I'm titling this video The National Drought of 2021. And that could be a little bit, how do you say it, exaggerated? Hyperbole? I think there's a certain person that says hyperbole. But the reason I'm saying this at this point is the maps. This is a drought monitor map. Okay, and it's for June, is it? Yes. So the first week in June, and we have almost the entire west region is under moderate, or well, moderate to severe drought, almost the entire West. And then much of the entire West is under extreme and exceptional drought. And then if you look at the upper plains and Midwest, we are at abnormally dry, moderate drought, and severe drought. Okay, so Michigan has all three. It has severe drought and moderate drought, and then the yellow, which is abnormally dry. So that goes into Wisconsin, Minnesota, and then look at North Dakota. So, and then even out west, you've got New York, Vermont, New Hampshire, and then you've got Virginia in the mid-Atlantic, Virginia, North Carolina, and then you've got some dry, abnormally dry areas in Florida. So I'm going to call it, it's above 53, or it's 53%, so it's above 50%. So I'm calling it a national drought. And then I guess the other reason to think of it as a national drought is that it's going to have economic impact, which will be national. So I'm already reading that farmers are not planting. So that's true in California, Arizona, and Utah, and then then North Dakota is not planting as much wheat. So and then livestock is going to be a problem. They're having to, what do you call it? Shrink the herds of animals. So I'm expecting that food prices are going to go up. I mean, meat, dairy, and then vegetables, etc. are going to go. All that's going to go up in price. So it could have a significant impact. Now, and then the other previous stuff I showed you that this is not, the last 20 years we've had abnormally dry conditions, drought, abnormally dry conditions and droughts for the last 20 years, since 2000, or last 30 years. So now, you can quibble or debate about whether this is global warming, but temperatures are higher, and that means that there's more evaporation, and so what moisture is in the soil is evaporated, and then and if we don't have precipitation, then snow melts earlier. So the snow melts earlier, so we're getting less snowfall. The snow that is there is melting earlier, and then it's evaporating quickly from the soil up into the atmosphere. So now you keep saying, or I'm thinking the skeptics keep saying that there isn't any global warming. I mean, how much more evidence do you need? I mean, so we had record global temperature 2 years ago, I think it was. 2 or 3 years ago. It was the hottest year ever recorded. So I don't know how much more evidence. And the last decade was the hottest decade on record. And the temperatures keep going up. So, and we'll have wildfires. The other problem is wildfires. So we had wildfires 2 years ago. And Trump went out there and said, rake them up. It's forest management. This is going to be the refrain from the right wing. It's going to be a simplistic talking point. Is you got big fires out there? No, we got to rake more. Got to do a better job of raking. I don't think hardly anybody believes that at this point. Does anybody believe that raking will solve the problem? I mean, at some point you're going to have so many acres of forest fire, it's just going to be, you're not going to have any much stuff to burn. But okay.
proceeding, we have all recently become aware of another insidious danger. It is as menacing in its way as those more accustomed perils with which international diplomacy has concerned itself for centuries. It is the prospect of irretrievable damage to the atmosphere, to the oceans, to Earth itself. Of course, major changes in the Earth's climate and environment have taken place in earlier centuries when the world's population was a fraction of its present size. The causes are to be found in nature itself, changes in the Earth's orbit, changes in the amount of radiation given off by the sun, the consequential effects on the plankton in the ocean, and in volcanic processes. All these we can observe, and some we may be able to predict, but we don't have the power to prevent or control them. What we are now doing to the world, by degrading the land surfaces, by polluting the waters, and by adding greenhouse gases to the air at an unprecedented rate, all this is new in the experience of the Earth. It is mankind and his activities which are changing the environment of our planet in damaging and dangerous ways. We can find examples in the past. Indeed, we may well conclude that it was the silting up of the river Euphrates which drove man out of the Garden of Eden. We also have the example of the tragedy of Easter Island, where people arrived by boat to find a primeval forest. In time, the population increased to over 9,000 souls, and the demand placed upon the environment resulted in its eventual destruction as people cut down the trees. This in turn led to warfare over the scarce remaining resources, and the population crashed to a few hundred people without even enough wood to make boats to escape. The difference now is in the scale of the damage we are doing. We are seeing a vast increase in the amount of carbon dioxide reaching the atmosphere. The annual increase is 3 billion tons, and half the carbon emitted since the Industrial Revolution still remains in the atmosphere. At the same time as this is happening, we are seeing the destruction on a vast scale of tropical forests which are uniquely able to remove carbon dioxide from the air. Every year, an area of forest equal to the whole surface of the United Kingdom is destroyed. At present rates of clearance, we shall by the year 2000 have removed 65% of forests in the humid tropical zones. The consequences of this become clearer when one remembers that tropical forests fix more than 10 times as much carbon as do forests in the temperate zones. We now know, too, that great damage is being done to the ozone layer by the production of halons and chlorofluorocarbons. But at least we have recognized that reducing and eventually stopping the emission of CFCs is one positive thing we can do about the menacing accumulation of greenhouse gases. It is, of course, true that none of us would be here but for the greenhouse effect. It gives us the moist atmosphere which sustains life on Earth. We need the greenhouse effect, but only in the right proportions. More than anything, our environment is threatened by the sheer numbers of people and the plants and animals which go with them. When I was born, the world's population was some 2 billion people. My grandson will grow up in a world of more than 6 billion people. Put in its bluntest form, the main threat to our environment is more and more people and their activities, the land they cultivate ever more intensively, the forests they cut down and burn, the mountainsides they lay bare, the fossil fuels they burn, the rivers and the seas they pollute. The result is that change in future is likely to be more fundamental and more widespread than anything we have known hitherto. Change to the sea around us, change to the atmosphere above, leading in turn to change in the world's climate, which could alter the way we live in the most fundamental way of all. That prospect is a new factor in human affairs. It's comparable in its implications to the discovery of how to split the atom. Indeed, its results could be even more far-reaching. We're constantly learning more about these changes affecting our environment, and scientists from the Polar Institute in Cambridge and the British Antarctic Survey have been at the leading edge of research in both the Arctic and the Antarctic, warning us of the greater dangers that lie ahead. Let me quote from a letter that I received only 2 weeks ago from a British scientist on board a ship in the Antarctic Ocean. He wrote, "In the polar regions today, we are seeing what may be early signs of man-induced climatic change. Data coming in from Halley Bay and from instruments aboard the ship on which I am sailing show that we are entering a spring ozone depletion, which is as deep as, if not deeper, than the depletion in the worst year to date. It completely reverses the recovery observed in 1988. The lowest recording aboard this ship is only 150 Dobson units for ozone total content during September, compared with 300 for the same season in a normal year. That, of course, is a very severe depletion." He also reports on a significant thinning of the sea ice, and he writes that in the Antarctic, he says, "Our data confirm that the first-year ice, which forms the bulk of sea ice cover, is remarkably thin, and so is probably unable to sustain significant atmospheric warming without melting. Sea ice," he continues, "separates the ocean from the atmosphere over an area of more than 30 million square kilometers. It reflects most of the solar radiation falling on it, helping to cool the Earth's surface. If this area were reduced, the warming of Earth would be accelerated due to the extra absorption of radiation by the ocean. The lesson of these polar processes," he goes on, "is that an environmental or climatic change produced by man may take on a self-sustaining or runaway quality and may be irreversible." That is from the scientists who are doing work on the ship that is present considering these matters. These are sobering indications of what may happen, and they led my correspondent to put forward the interesting idea of a World Polar Watch, amongst other initiatives, which will observe the world's climate system and allow us to understand how it works. We also have new scientific evidence from an entirely different area, the tropical forests. Through their capacity to evaporate vast volumes of water vapor and of gases and particles which assist the formation of clouds, the forests serve to keep their regions cool and moist by weaving a sunshade of white reflecting clouds and by bringing the rain that sustains them. A recent study by our British Meteorological Office on the Amazon rainforest shows that large-scale deforestation may reduce rainfall and thus affect the climate directly. Past experience shows us that without trees there is no rain, and without rain there are no trees. Mr. President, the evidence is there. The damage is being done. What do we, the international community, do about it? In some areas, the action required is primarily for individual nations or groups of nations to take. I'm thinking, for example, of action to deal with the pollution of rivers. And many of us now see the fish back in rivers from which they had disappeared.
My thanks to Tony Heller for checking my channel for accuracy in his video Debunking the Debunker. A lot of people asked me to respond, so I'm happy to do so. I'll go through his claims in chronological order. Here's the first one.
He claims that a tiny bit of cooling triggers ice ages and a tiny bit of warming ends them.
Well, the researchers I cite conclude this, not me.
But he doesn't provide any evidence of the magnitude of these changes.
Actually, I do. I not only give the figures, I cite and show the study they came from. This is from my video, Does CO2 Lead or Lag Global Warming? A paper by Laureus et al. Shows that insulation has varied by only 0.7 watts per square meter over the last 160,000 years. In other words, the tiny amount of forcing due to the Earth's orbit wasn't enough to defrost miles of thick ice covering a large part of the planet.
Listen carefully to what he says here.
But each time, something had to act as that initial trigger. Something had to nudge the round weight just a fraction. A strong contender has always been regular cyclical deviation in the Earth's position or orbit, changing the amount of sunlight the Earth received. Whatever it was, in the depths of the Ice Age, this change melted a tiny part of the ice sheet and released carbon gases from the soil and from the warmer oceans.
Whatever it was? He doesn't actually know what the trigger of the ice ages is, but he claims to know that the magnitude of it is small.
But didn't I just explain what researchers think it was? Tony even played the clip. A strong contender has always been regular cyclical deviation in the Earth's position or orbit, changing the amount of sunlight the Earth received. These orbital movements and wobbles are called Milankovitch cycles. In another video, I explain that again. Researchers say carbon dioxide was not the cause of the initial warming during any of the recent deglaciations. The most likely trigger was the Milankovitch cycles, changes in the Earth's tilt and orbit that caused more insolation.
What if the effect of those orbital cycles was actually very large, then his entire theory goes down the drain immediately?
But as I point out, researchers have calculated that they aren't large. And again, it's not my theory. Professional researchers know very precisely what these orbital variations are, and they can calculate within given margins of error how much they affect the energy budget of the Earth. Of course, Tony can speculate that it's much bigger or much smaller. He's free to imagine any figures he likes. But researchers can't do that. They have to go with what the measurements and calculations show. And as a science reporter, I can't do that either. I have to accurately report their results. Tony goes on to describe how a small amount of warming causes oceans to release CO2, since carbon dioxide is less soluble at higher water temperature. I explain exactly the same thing, so no argument there.
So the relationship here, as Potholer correctly stated, is that CO2 follows temperature. Temperature changes first, and the CO2 changes later. What he blew over in his discussion was that Al Gore said the exact opposite. He tried to make it sound like CO2 drove the temperature.
He did indeed, and I pointed out his mistake very clearly. In his film An Inconvenient Truth, Al Gore used a graph like this to show a correlation between carbon dioxide levels and increased temperatures. But he obscured the fact that the carbon dioxide increases lagged the temperature increases by 800 years. So I didn't blow over this at all. It's right there.
Billions of school children around the world have been lied to about this topic, and Potholer didn't seem to think that was very important.
Now, that's a bit unfair. I think that's extremely important, and if you'd asked me, Tony, I would have been very happy to tell you that. I've made no indication in any of my videos that I'm not concerned about children being misinformed about science, whether it's by Al Gore or Laurie David or anyone else. I've frequently spoken out in my videos about the need to stop junk science creeping into classrooms, and I'm happy to repeat that now. I've also said schools need to spend more time teaching children how to tell the difference between real science and junk science on the internet. But let's just get back to what Tony claims I agree with.
So the relationship here, as Potholer correctly stated, is that CO2 follows temperature. temperature changes first, and the CO2 changes later.
Well, I didn't say the relationship here is that CO2 follows temperature, obviously, because this is a graph covering several glacial cycles. What I said was that CO2 followed temperatures in the early stages of deglaciation in the southern hemisphere, because I'm reporting the conclusion of scientific studies. In the latter stages of deglaciation shown on the graph, and in the northern hemisphere, CO2 led temperature rise. So just as it's wrong for Al Gore to give the impression that CO2 always leads temperature changes, it's wrong for Tony to give the impression that CO2 always lags. If Tony's concerned that billions of school children are being lied to about this topic, and I don't doubt his sincerity, then I hope he'll join me in insisting that school children should be told what the science says, which is that carbon dioxide does both. It leads and lags temperature at different stages in the glacial cycle.
Now let's go back and look at the ice core graph again. The graph shows swings in temperature of about 10 degrees centigrade during glacial cycles. These correspond with swings in carbon dioxide level in the atmosphere of about 100 parts per million. Now remember what Potholer said. He said that a very small change in temperature causes feedback from carbon dioxide, and that we get a 10-degree swing in temperature from a 100 part per million change in CO2.
Does anyone remember me saying that we get a 10-degree swing in temperature from a 100 part per million change in CO2? No, because that would imply a ridiculously high figure for the Earth's sensitivity, which is how much the Earth responds to carbon dioxide forcing. Did Tony show a video clip of me saying that? Of course not, because I never said any such thing. And yet, when Tony made that claim, some people simply believed him without checking. That's why I got a couple of rather abusive messages on my channel.
And that is completely ludicrous.
It is, which is why I didn't say it.
Not even the most outrageous claims of climate sensitivity come anywhere close to that.
I didn't say that, Tony. Okay, just to settle this, here's what I did say about climate sensitivity. And these estimates show that for a doubling of CO2 concentrations, we should see a rise in global temperatures of between 2 and 4.5 degrees. Now, that's what I've reported. So what does Tony Heller say?
According to the United Nations Intergovernmental Panel on Climate Change, climate sensitivity is somewhere between 1.5 degrees centigrade and 4.5 degrees centigrade for a doubling of CO2.
So it turns out Tony agrees with my reporting of the sensitivity estimates. There's a reason for the small half a degree difference in the lower estimate, but this is essentially the same result. So I didn't say that a 10-degree rise in temperature came from a 100 part per million rise in CO2, and certainly no study I've ever read has made such a claim or given that interpretation to the data used to make the graph. Tony Heller assumed that that's what the graph shows because he made a basic error when he tried to interpret the graph for himself. To find out what he got wrong, we first need to find out where he got this graph from. Tony doesn't tell us because he doesn't give his sources, so I had to track it down myself. It's been passed around the internet a lot, but by searching the image and screening the time it was first uploaded, I finally found the first posting of it from a slideshow, and that led me to this slide presentation at Harvard. The data for the graph, according to the authors, came from this paper by Petit et al. Reading Petit's paper, which gives us more detail about how the data were gathered, it's clear that the temperature scale on Tony's graph is not measuring average global temperature. The authors measured oxygen isotopes in the air bubbles trapped in the ice, which are good proxies for air temperatures. So, as they explain in the study, they're measuring temperature at two places: where the precipitation formed, in other words, where the snowflakes formed, and where the snowflakes fell and were later compressed into ice. To put it in even simpler terms, they weren't measuring global temperatures at all. They were measuring Antarctic temperatures. So Tony's wrong to infer climate sensitivity from this, because climate sensitivity is based on average global temperatures, like the average global temperatures Tony looked at when he cites the IPCC result. I'm sure everyone understands the difference between these average global temperature figures and these Antarctic temperature figures.
Under Potholer's feedback theory,
Oh, my theory, mate.
we would have expected that as CO2 spiked, temperatures would have gone up too.
Okay, there's obviously a genuine belief that this is my theory, so I'd better explain that the conclusion that post-glacial warming was amplified by positive feedback is a well-accepted scientific principle. Anyone with a passing interest in climate science would surely be aware of the mountain of studies that have been written about it. I've explained these positive feedback factors many times, citing scientific studies. So if anyone thinks it's my theory, I'm very flattered, but I'm not nearly smart enough to have discovered it, so please read these studies for yourselves. And it isn't a recent phenomenon invented by fraudulent scientists. Positive feedback as a forcing amplifier has been understood since at least 1969, when Charles Keating of the Scripps Institute wrote about it. This summary explains positive feedback very well, published in 1979. So to answer the question of whether temperature goes up after CO2 goes up, yes, researchers have shown that it clearly does. What Tony is wondering is why, therefore, don't temperatures keep rising when CO2 hits its peak?
We would have expected that as CO2 spiked, temperatures would have gone up too.
Well, when something doesn't make any sense to me, I don't assume that the science must be wrong. I try to find out if professional researchers have an answer. And of course they do. What researchers have found is that towards the end of each deglaciation, the forcing stops and the Earth reaches what's called equilibrium temperature. It enters an interglacial. Now, negative forcing takes effect. The most likely reason for this change is the Milankovitch cycles. As the southern hemisphere receives a little less insulation, the oceans cool, dissolving more CO2, which reduces CO2 concentration in the atmosphere. And colder conditions create more ice, increasing albedo and reflecting more sunlight. It's the reverse of what happens at the start of a deglaciation.
Look how quickly we come out of ice ages, starting with very low levels of CO2. This is the exact opposite of what we'd expect from CO2 theory.
Of course, you only need to read the published studies to see that these observations aren't the opposite, they're completely consistent. To recap briefly, the research shows that a small increase in insulation warms the oceans, and that causes CO2 to come out of solution. Now, if CO2 wasn't a powerful greenhouse gas, that would be the end of the line. Research has shown that the small increase in insulation alone wouldn't be enough to melt all the ice sheets. So there would be no way to explain how each glaciation came to an end. But if CO2 is a powerful greenhouse gas, then the result would be more warming, amplified by positive feedback, bringing us quickly out of the glaciation. So how can this process be the opposite of the theory that CO2 is a powerful greenhouse gas when the entire sequence of events depends on it?
In 2004, the guy who's in charge of temperature records at NASA, Gavin Schmidt, said, "During recent decades, surface temperatures decreased significantly over most of Antarctica." Let's remember now that we're talking about Antarctic ice core records. Gavin Schmidt says the temperatures are going down as CO2 has spiked. Under Potholer's feedback theory,
Not my theory, mate.
we would have expected that as CO2 spiked, temperatures would have gone up too.
Okay, a lot of assumptions and misunderstandings here. The problem seems to be that Tony's only reading the abstract of the study on a NASA website. He needs to read the paper itself, where the source of his misunderstanding is revealed. In the paper itself, the authors show that ozone depletion and greenhouse gases exacerbated a phenomenon called the Southern Annular Mode, or the SAM, which defines the changing position of the southern wind belt. According to the study, 90% of the cooling at South Pole and East Antarctica stations correlated to the SAM. So their conclusion was that recent cooling over the Antarctic continental interior has likely been caused by both ozone depletion and greenhouse gas increases. Now that's a clear distinction between global warming now and global warming during deglaciations of the past. Firstly, ozone depletion over Antarctica is not something known to have occurred or been a factor at the end of each deglaciation. Secondly, while greenhouse gases are the initial forcing now, during deglaciation periods the initial forcing was increased insulation, as other studies I've cited explain. And the third difference, which wasn't in the Schindel and Schmidt paper, but which has been shown in other studies, is that during deglaciations, the initial forcing was insulation in the southern hemisphere, much closer to Antarctica. Now the initial forcing is CO2 in the northern hemisphere, much further away. So, of course,
been times in the past when we've seen receding glaciers and receding ice sheets and comments about, my goodness, things seem to be going in the opposite direction, glaciers, and what's the difference now?
Right. So for measuring, say, the what Greenland is doing, some of that work is done by weighing the ice sheet using the GRACE gravity satellites, which is truly wonderful. It's like watching cars on a roller coaster, and the one going down gets away from the one that's going up, and then the one going down catches up, and you watch.
As I understand, it's fascinating that we've satellites sort of pursuing each other, and gravitational attraction slows one down, and relative to the other, by measuring the rate of that different speed, you can tell how much mass is underneath you, and as that mass declines, there's less slowing down.
Perfect. I should retire and let you teach this.
I just think it's beautiful.
This
really,
is beautiful.
really
Okay.
interesting.
So you weigh them using GRACE, but then you measure changes in surface elevation. Is it going down or up using a radar or a laser from a plane or a satellite? And all of those have been done. And then you figure out how much snow is being added and how much meltwater is leaving and how much ice is leaving. And then you compare all of these to see if they give the same answer. And all of them indicate shrinkage of Greenland. You're certainly correct that the ice has grown and shrunk in the past, and I had the honor of serving for the U.S. government on the Climate Change Science Program on a report on the history of the Arctic, and what we found was very clear for Greenland. When nature made it warmer, Greenland got smaller, and when nature made it colder, Greenland got bigger. And we are now making it warmer, and Greenland is getting smaller.
How do we know it's we, not nature? We've got the increase in CO2. But the skeptic would argue, well, wait a second, I can go back to 1927 and find articles about glaciers retreating. What's the difference? I mean, you could look at a football team and say, well, they were losing back then and they're losing now, so what's the difference?
Right, so the first one is the physics. We just cannot get away from the warming effect of CO2. It's been known for over a century. It was really clarified by the Air Force, who were actually interested in what wavelength should I use for the sensor on my heat-seeking missile. But CO2 interacts with radiation, and there's enough CO2 to make a difference. And we just can't get away from that physics. The second one is looking at, is there any other possible thing to explain this? And it really took, I'm sorry, sir, it took a few $1 billion of your money and about 30 years to say that there's nothing else that we can find in nature to do this. And this is because satellites are expensive. But someone says it's the sun. Well, then you need a satellite to watch the sun to see if the sun is getting brighter, but it isn't. And if someone says, well, it's volcanoes, then we need a history of volcanoes, and we need to know what they're doing. And if someone says it's cosmic rays, we need cosmic ray monitors. And it's taken sort of 30 years to get to the point of saying, no, we've looked really hard, we can't find anything else. Then there's a third piece, which is the fingerprinting, which is what Dr. Santer was discussing. If you were to say, okay, yeah, I know we spend a lot of money on satellites, and the satellites say the sun is not getting brighter, but maybe the satellites are wrong, and the sun's getting brighter and we can't see it. That makes a prediction. It gets warmer down here, and it gets warmer way up at the top of the stratosphere. CO2 says warmer, colder. What's going on? Warmer, colder. So the fingerprinting in time and in space says that we got it right on the other two pieces. It's mostly us now.
I want to be clear, it's not my money. It's your money.
Okay. Thank you, sir. Absolutely.
It's the taxpayers' money. I never
Absolutely.
forget it. But I think at the same time, the consequences adversely, if we don't address our energy dependence, and if we don't address apparently, in my judgment, real impacts of this will vastly exceed $1 billion. And if we can make some measured changes to reduce that impact, the savings will exceed the expenditures by a darn sight. Dr. Santer, you might want to comment. Dr. Michaels, then I'll recommend my colleagues.
Yeah, I just wanted to comment briefly on what Dr. Ali said about the fingerprinting. We've known that increases in CO2 have this characteristic fingerprint of warming the lower atmosphere, the troposphere, and cooling the upper atmosphere. since about the late 1950s, early 1960s, when people performed the first numerical model experiments and doubled CO2, and they saw this characteristic pattern of cooling of the stratosphere, warming of the troposphere. Very robust. We see that in virtually every model experiment that's been performed. And as mentioned, we also see it in observations too. We see it in satellite data, we see it in weather balloon data. Now, people often say these computer models are not falsifiable. They make predictions that we can't test. That's not true. Back in the 1960s, when Suki Manabe and his colleagues at the Geophysical Fluid Dynamics Lab in Princeton made these calculations and doubled atmospheric CO2 and saw this fingerprint, we didn't really have the observational data to see whether the stratosphere was actually cooling, whether the troposphere was warming. They have. The stratosphere has cooled, the troposphere has warmed. That fingerprint is robust, and it's just not consistent with other natural causes.
Dr. Michaels, did you care to comment on any of this?
I have several comments I'd like to make. We'll probably take up the rest of the day, so I'll just limit. That won't happen. No, it certainly won't. I will limit it to the notion of what we're talking about here. You've noticed is that everybody says that the planet's warmed up and that people have something to do with it. So what really matters is the magnitude of it. If I can have the clicker. This is just going to take a second. It's not going to be as bad as you think. There it is, right there. This is the warming from the IPCC, from the CRU record from 1950. And our Environmental Protection Agency, which, as you know, has taken over the regulatory aspect of this because of what happened in the Congress, issued an endangerment finding on warming. And they asserted in their endangerment finding that more than half of the warming of the late 20th century is a result, very likely, a result of human greenhouse gases. More than half means more than 50%. Late 20th century means after 1950. You agree with that? Second half of the 20th century. Well, in fact, there are 4 different factors that are totally independent of the greenhouse effect. One, that we underestimated sea surface temperatures from 1944 through 1965. That was published by Thompson in Nature magazine. Number 2, that there are non-climatic subtle effects on the temperature history. That was published by McKittrick and me in Journal of Geophysics. Atmospheres. Susan Solomon found that water vapor in the stratosphere is responsible for a lot of the secular changes. And that we don't know why water vapor is fluctuating in the stratosphere. It's not a greenhouse effect. I mean, it's not apparently from greenhouse gas emissions. And number 4, Ramanathan at Stanford said, well, about 25% of the warming is the result of black carbon going in the atmosphere. That's also not a greenhouse gas. When you add all those up, the warming drops from 0.7 to 0.3 degrees. So the assertion that over half the warming is a function of greenhouse gases is challenged by 4 completely independent factors. I think we've got a lot more work to do on this, frankly.
Any very quick response to that?
Yes, might I respond
Please,
to that?
very quickly.
Dr. Michaels' analysis is wrong. Sorry, it's just completely incorrect. What he's attempted to do here is explain the observed temperature change over the last 60 years, from 1950 through to 2010. And he said that the estimated total change in temperature is 0.7 degrees. Now, he's identified 4 things: economic activity, black carbon, errors in the sea surface temperature data, and stratospheric water vapor, and said, I think all of those things have had a warming influence, so I'm going to subtract them from this 0.7 degrees, and I'm left with 0.3. 0.3 is less than half of 0.7, therefore the IPCC is wrong. And the conclusion that more than half of the observed warming over the 20th century was due to very likely due to increases in greenhouse gases is one of the central conclusions of the IPCC. So if Dr. Michaels is right, that central conclusion is wrong. What Dr. Michaels did not mention either here or in his written testimony is the cooling effect of sulfate aerosols, which has already been discussed at this hearing. If you indulge me for a moment, I'm just going to bring up one slide here. Now, our best estimate of that cooling is, this is a slide from a paper published in 2006 by Peter Stott at the Hadley Center. And what you see in the bottom are 3 different climate models, and it's the estimate of their sulfate cooling caused by the scattering effects of sulfate aerosols over the 20th century. It's negative. Now, if you assume conservatively that cooling effect over 1950 to 2010, the period Dr. Michaels looked at was, say, minus 0.4 degrees Celsius over that 60-year period, and you assume that Dr. Michaels was completely correct in the estimating the magnitude of the 4 factors that he removed from the observations, you'd be adding minus 0.4 and plus 0.4. You'd get to 0. So you still need to explain 0.7. You need to get to the observed total temperature change over the 60-year period. What could that be? Could it be the sun? No way. It couldn't be the sun. If solar effects were that large on the 60-year timescale, we'd see a huge 11-year cycle in the temperature data. We don't. Could it be volcanoes? No, it couldn't be volcanoes. Could it be some mode of natural variability, some internal oscillation of the climate system that could generate that 0.7 degree temperature increase? Not plausible. The most plausible explanation is an increase in atmospheric CO2. We know CO2 has changed. Again, that's not some assertion, that's not supposition, we know that. So what the IPCC found here and what they reported on was that actually the change in temperature due to greenhouse gases, which is what you see in red, was larger than the actually observed change in temperature, which is that horizontal black line. So the greenhouse gas signal was offset, that's our best understanding, by the cooling caused by these sulfate aerosols. They scatter incoming sunlight and they also change cloud properties.
Yeah,
Excuse me.
Greg,
Pardon for a second. The IPCC gives the range of perspective.
Access Vision. Your voice, your community.